Okay, good afternoon, everyone. We will start today's lecture that is going on cluster analysis or unsupervised learning in data mining. So, in last class, I just gave an initial discussions, or I did an initial discussion over cluster analysis or unsupervised learning, and I already discussed about what is clustering and what are the various features of clustering, how we can measure the a good quality of clusters. Those things I already discussed in the last class. Okay, let me share my screen first. I think this screen is visible to everyone. So in last class, I already discussed about what is cluster analysis. Okay, then I discuss about the various applications of clustering or multidisciplinary applications of clustering in real life or in various domain of computer science. Okay, then I discussed about the quality of how we can measure the good quality of clustering technique. Means whether a cluster is a good quality cluster or bad quality cluster based on the intra-class similarity and inter-class similarity, we can do that measurement. Okay, that I already discussed. Now today, after giving some basic discussions of how we can what are the various kinds of data or what are the various types of matrices or data matrices on which the clustering will perform, and then we will move into the details of various kinds of clustering algorithms as per our syllabus or as per our curriculum. Okay, and how those algorithm is working to cluster a set of objects that is actually spreading in a free space, or that is actually located in a free space, and how the different clusterings are doing clusters of those objects. Okay, that we are going to do, that we are going to learn. Okay, one by one. So measure the quality of cluster, that I already discussed in the last class, that it is hard. It is similarity is expressed in terms of distance function. So in clustering analysis, whatever clustering analysis we are going to use in future, it may be a partitioning based method, or it may be a density based method, or it may be a hierarchical based method, or grid based method. Whatever clustering you are going to learn in future, not only in this curriculum, beyond this curriculum, whatever unsupervised learning in terms of cluster analysis you will learn, all the cluster analysis is generally based on a special kind of function, and that is called distance function. It plays a very vital role, or very key role of any kind of clustering process. Okay, so distance function will be represented in the form of d of I comma j. D represents the distance variable, I represents the object I, and j represents the object j. That means the distance between these two objects will be represented by the help of this d of I comma j metric. Okay, now there are several functions that we are going to use, or we are going to learn to measure the distances between two objects I and j, that we will learn, that I will show you. Okay, today I will show you what are those different kinds of functions. You can use any one of the functions as per the application, as per your choice, or as per the needs of the quality of the objects that you have in your hand as a free space objects. Okay, so you can apply any one of the, you can choose any one of the distance measure functions. Okay, now there is a separate quality function that measures the goodness of a clusters, which I already told. The definition of a distance function are usually very different for interval scaled, Boolean, categorical, ordinal ratio, and vector variables. These are the various kind of variables or various kind of data or types of data on which cluster analysis or clustering process is going on. Okay, these are the various kind of data that you are facing in future while you are going to handle the real life data. Not only numerical kind of data, apart from numerical, it is interval scale data is also a numerical kind of data. So apart from this numerical kind of data, you will also face categorical data, you will also face to handle ordinal data, you will also face to handle Boolean kind of data. Okay, so these data vector kind of data you are going to apply. Okay, like quantum computing, you have this quantum computing is nowadays a very buzzword, and I know that you are already familiar with this term quantum computing. So while you are performing quantum clustering, that means you are performing clusters in a quantum domain. Okay, then you will have to perform the clusters on vector variables. Okay, because in quantum domain all the data are generally represented in the form of states, and states means the vector states. Okay, so in quantum computing, whatever clustering you are going to apply, or whatever clustering you are going to use, that will be applied on a vector kind of data or vector kind of variables. Okay, So these are the various applications on which kind of data you have, and based on that kind of data, what are the various kinds of clustering you can apply on that data. Okay. Now, um, what are the requirements of clustering in data mining? What are the various kinds of requirements in clustering in data mining? So there are various requirements: scalability of the clustering, ability to deal with different types of attributes, ability to handle dynamic data, discovery of clusters with arbitrary shape, minimal requirements for domain knowledge to determine input parameters, able to deal with noise and outliers, incentive to order of input records, high dimensionality, incorporation of user-specified constraints, and interpretability and usability. These are the various requirements of clustering in data mining. So if we talk about the clustering, these are basic stages of clustering, that how the clustering is actually happened. That is a basic block diagram of the entire clustering process. Okay, input data is there. So this is a huge useful feature extraction will be performed. Okay, before applying the clustering on the input data, you may perform a feature. This is actually optional stage. This is not a mandatory stage, but for the real world application, most of the cases we actually apply the feature extraction or feature subset selection process to reduce the size of the attributes or the size of the dimension of the data sets. Okay, dimension reduction. Okay, that we can perform with the help of feature extractions or feature reduction, right? Or feature selection. Now, after feature selection, feature extraction, then we actually trying to find the inter-pattern similarity with the help of distance function. And based on this inter-pattern similarity of the distance function, we can group the number of objects or observation into a similar kind of clusters. I already told in the last class, the objects which are present within a same clusters, okay, the objects which are present or the observations which are present within the same cluster should be similar with each other, must be similar with each other. And the objects of two different cluster must be dissimilar of each other. Okay, that's why the intra-cluster similarity should be high and inter-cluster similarity should be low. Okay, intra-cluster similarity means within cluster, the similarity between objects, that is intra-cluster. And inter-cluster means with two different clusters, the similarity between two different objects. Okay, so always inter-cluster similarity should be high, it should be low, and intra-cluster similarity should be high. Okay, now based on this grouping, a feedback path should be there. That means this grouping process should be continued or will be continued until there is no more input data exist. What I'm trying to say, so I'm going to show you in very detail more while we are going to discuss some of the clustering algorithm, that how this grouping process is actually done in terms of clustering. Actually, when the new data has been inputted, we have to initialize some basic some data as a cluster centers. Okay, suppose these are four clusters, sorry, five clusters are there. So we will consider five data as a cluster center. We will assume it. Okay, in some of the algorithm we will assume it the five data as a five different cluster centers. Okay, and when the new data is coming, we'll have to measure the distance of the new data from individual of those cluster centers, and that distance which from which cluster center the distance is minimum of the new data, the new data will be inserted or will be grouped as a part of that particular clusters. And these things will be, it is an iterative process, is that these things will be repeated or these things will be looping or iterative until all the input data are clustered properly, no input data has left. Okay, so this is the overall basic stages in clustering process. Okay, do you understand it? Is it clear to everyone? These are basic stages in clustering. Is it clear to everyone? This diagram is clear to everyone?
Sir, can
Yes,
you
sir.
please repeat this, sir?
Yes, yes. Look, when the new data has been inserted, what is the basic job of clustering? Okay, your conception is fully clear while I'm giving some examples, numerical examples in front of you. Okay, with the help of some of the important clustering that we are going to learn, like k-means, db scan, that we are going to learn those. Your conception will be fully clear at that time. Just now, you just make an overall idea that how the clustering is actually happen. Suppose you have a set of input data in your hands, and suppose you are trying to make five clusters. Okay, so to build five clusters, you have to consider five cluster centers. Okay, which are called the cluster mean points or center points. Okay, whatever you say, cluster mean or cluster centers. Okay. Now, how you can consider these cluster centers from this input data? You just assume, okay, five different data for five different cluster centers, right? Now, apart from this data, whatever data you have, whatever data you have, suppose this data set contains suppose 10 data, right? So among these 10 data, 5 data has been already you have been chosen as a cluster centers, or you have assumed as a cluster change centers. So apart from the 5 data, the rest of the 5 data should be clustered properly, or should be part of which cluster, that you have to determine. So that's why you have to use, or you have to take the help of the distance functions or distance metrics, which I already discussed, d of I comma j, where I is a cluster center of each and individual cluster, and j will be your new data, the rest of the data যে বাকি পাঁচটা data পড়ে রয়েছে, that is j, j1, j2, j3, j4, j5, and I is your 5 cluster centers, I1, I2, I3, I4, I5. Okay, so distance of I1 comma J1, distance of I2 comma J1, distance of I3 comma J1, distance of I4 comma J1, and distance of I5 comma J1, you have to calculate. And which distance is the minimum distance or smallest distance? That means the distance of that new input data is smallest from which cluster? That cluster will be chosen as a that data will be chosen as a part of that cluster, or that data will be inserted into that cluster. And this process will be repeated. It's an iterative process, and this process will be repeated until all the data will be clustered, or will make a group properly within this among these 5 clusters. Now it may be possible some of the data are not fitted with any clusters. Suppose you are measuring one data you have, and you have measured the data from cluster centers with the help of distance functions, and you have found that the distance that the new data has been calculated is very absurd. Absurd means no distance, means all the distances are from compared to other data distances, that the distance of that particular data is looking very absurd, a very big distance it has. কোনো ক্লাস্টারের সঙ্গে ডিসটেন্সটা মিনিমাম হচ্ছে না। Okay, suppose you have a threshold and that distance is beyond that threshold. Now you are getting very much confused that data should be part of which cluster, because the distance is totally absurd, and it is not minimum from any other clusters. পাঁচটা ক্লাস্টারের কোনোটার সঙ্গেই মিনিমাম হচ্ছে না, বা স্মলেস্ট ডিস্টেন্স পাচ্ছি না, বা ডিস্টেন্স একটা অ্যাবসার্ড ডিস্টেন্স পাচ্ছি। So that data will be treated like a noisy data or outliers. So outliers play a very vital role in clustering. Okay, noisy data or outliers. Please remember these things. Okay, so noisy data is actually fallen outside of all these clusters. Okay, it can be anywhere outside of all 5 clusters. Okay, it should not be part of any one of these clusters. Clear? Is it clear? বুঝতে পারলে?
Yes, sir.
These are the basic stages of any clustering technique. Okay, so let me clear your concept first. Let me give you one example. So these are the broadly classification of the clustering. Clustering are classified into these various types: classical partitional clustering, hierarchical clustering, density-based clustering, grid-based clustering, model-based clustering, constraint-based clustering, and high-dimensional data clustering. 1, 2, 3, 4, 5, 6, 7. Total 7 types of clustering techniques are available. Among these 7 types of clustering technique, we are mainly focused on the first 3 types according to your curriculum: classical partitional clustering, hierarchical clustering, and density-based clustering. Right? Now, within classical partitional clustering, there are 2 kinds of algorithm that we'll have to learn. One is k-means, and one is k-modes or k-medians, k-medioids. Okay, the same thing, either k-modes clustering or k-medioids. And another one is, the first one is k-means. Now, within hierarchical, there are some other kind of clustering algorithm like divisive clustering, agglomerative hierarchical clustering, divisive hierarchical. These are the main 2 one, agglomerative and divisive. And these rock and birch are the 2 very special kind of hierarchical clustering. That will be not part of our syllabus, rock and birch. We are mainly focusing on divisive and agglomerative clustering. Okay. And in density based clustering, we are mainly focusing on db scan clustering. We are not focusing on optics. Okay. So these are the various kind of clustering. You have understood that there are such a widespread of different kind of clustering. So which type of clustering you are going to use? That is totally depends on your applications, on the structure of your data set. That totally depends on it. Okay. So these are the typical requirements of clustering. What are the typical requirements? Scalability of a clustering. Scalability means clustering generally works well for the small data sets, okay, which has a fewer number of objects and fewer number of attributes, right? But for the large data sets, which kind of clustering is suitable, okay, that you will have to choose, okay, that you will have to consider, okay, and this is called a scalability. That means when the data set size is large, then which type of clustering you are going to choose, that is also a case of consideration, okay. Now, second is ability to deal with the different types of attributes. Now, different type of attributes mean different kinds of data. I already discussed about it. You may have some interval scale data. You may have binary data. You may have ordinal data. You may have categorical data. You may have vector kind of data. So, which kind of clustering is suitable and how your clustering is working on different kinds of data, that is also very important measure or requirements in case of clustering. These are the various requirements of clustering. Scalability, ability to deal with the different types of attributes. Third requirement, discovery of cluster with arbitrary shape is very important. We generally use several distance measure functions to calculate the distance or to make the clusters or to make the group of objects to form a cluster. Okay, and this cluster size and shape is actually varied. আমি এখানে যে ছবিগুলো দেখিয়েছি, all the pictures are generally a similar kind of shape of clusters, which is called oval shape cluster. But that doesn't mean that always the clusters are in oval shape. It doesn't mean that always the clusters are in oval shape. The cluster may be in different shape as well. Like in this case. Look, these are the various kinds of clusters also available. Cluster A shape hoy. Okay. Cluster can be these small circle shapes. Okay. Cluster can be these ring shapes. So cluster can be any shapes. Okay. And this is actually called a this is actually a requirement. This is actually a requirement and discovery of clusters with arbitrary shape. Okay, what type of shape you have made with the help of applying the clustering algorithm, that is actually a discovering a clusters with arbitrary shape. Arbitrary means যে কোনো shape হতে পারে. It is not always circle or not always oval, not always a ring shape. It can be any shape. Okay. Now, fourth one, minimum requirements for domain knowledge to determine the input parameters. So you require a minimum knowledge about the input parameters, minimum domain knowledge to for the input parameters. Okay, which is difficult to determine because you don't have a domain expert. Okay, because it is unsupervised learning. I already told, and in case of unsupervised learning, you don't have a domain expert. Okay, you don't have any supervisor or teacher like a classification. Unlike a classification, you don't have this. So it's difficult to acquire domain knowledge for regarding the input parameters. Now the fifth requirement, that ability to deal with noisy data, that is very important. Clustering analysis should be able to deal with your outliers or noisy data or missing data or erroneous data. Your clusters analysis should have that property. And some clustering algorithms are very much sensitive to such kind of noisy data or outliers. Outliers, I have already told. Okay, the data which is not part of any clusters are called outliers or noisy data. That means distance measure করার পর from all the cluster centers, if you measure a distance from a particular data and if you found that a distance is totally looking absurd, it is beyond the threshold of the distances, you cannot insert that particular data to as a member of any of the clusters, then that data will be considered as outliers or erroneous data or noisy data or missing data. Okay. Now incremental clustering, that I am going to discuss very soon. What is incremental clustering and how we can handle a dynamic data, okay, with the help of incremental clustering, that I am going to discuss. Okay. And that incremental clustering I actually did as a part of my research work in my masters. Okay. I will discuss about it. Now, high dimensionality, what are the various algorithms that are clustering algorithms are available to handle the high dimensional data sets or high dimensional attributes? As all of you know that in data warehousing, in real life data warehousing or data marts, are generally deal with the high dimensional data, various dimensions, several multi-dimensional data. আমি এক্ষুনি কিছুদিন আগেই পড়িয়েছিলাম data warehousing. So multi-dimensional means it has a very high dimensional kind of concepts are there in case of real world data warehousing. So what are the clustering should be good for handling the high dimensional data, that is also a case you need to be considered. Okay. So these are the various requirements of clustering techniques, right? Now these are the various kinds of clustering. Okay, partitioning based method. Okay, and which is nothing but an iterative process that we are going to learn today. How the partitioning based method is working. Then hierarchical methods. Okay, so hierarchical term, you are familiar with this term, hierarchical database. You have already learned in case of the database management system. That means it is looking like a hierarchical form. Okay, it's looking like an inverted tree structure. That is hierarchical structure. Okay, then density based clustering. Okay, and then grid based clustering, model based clustering, that we are going to, that just this defined kind of clustering, you just need to know one or two lines regarding those clustering. Okay, and we are going to mainly going to focus on partitioning clustering as part of our curriculum, hierarchical clustering and density based clustering. These three kind of clustering we are mainly going to focus, and for the rest of the clustering you just need to know what are those clusterings, and just what is actually did, what is the applications of those clustering, that will be enough. You don't need to know about the details of those clustering. Okay. Okay, so now before I'm going to start with the partitional, one of the partitioning based clustering, I want to discuss with you the various kinds of data clustering. Okay, the various kind of data that will be useful, or that will be used as a part of clustering. That means the types of data on which clustering algorithm is going to be applied. Okay, তার মধ্যে কিছু ডেটা তোমরা নিজেরা জানো, already I have discussed about it. আমি just overall বলছি. So these are the two kind of data structures. Is looking in front of you. Check this slide. These are the two kind of data structures on which we can apply our clustering techniques. Okay, the first data structure is looking like a data matrix. Okay, it is also called a two mode data structure, or it's looking like a data matrix, and it is also called object by variable structure. কি বললাম? Object by variable structure, where this n represent, np is the final term in n cross p, where n represents the objects and p represents the number of variables or number of features of that object. As for example, আমি বলে দিচ্ছি, as for example, suppose you are going to calculate the feature of a person, of a class of all the students of a particular class. You are trying to calculate the features of all the students of a particular class. So students means actually a person or a candidate. Okay, so what are the features that you are going to be considered to calculate the overall quality of the students? Okay, so you are going to take the features like age of the student, height of the student, weight of the students, gender of the students, and so on. This kind of features you are going to consider to calculate. So these features are generally called p variables. P number of features or p number of variables, right? This small p will represent that kind of feature. And n represents the number of objects or number of students present in your class. So in terms of clustering, n represents the number of objects present in the free space on which you are trying to apply the clustering, and p represents the number of features each and every object associated with. Is it clear to everyone? Up to this, anyone has any question, you can ask me. Up to this, anyone has any question, you can ask me.
No, sir.
Is it clear to everyone? দেখো কোনো ডাউট থাকলে জিজ্ঞাসা করো.
No, sir. Clear.
Now, dissimilarity matrix. It is also called one mode matrix. Can anyone tell me what is dissimilarity matrix? এটা কি? How it will look like? Any idea about this? I have already discussed about this one. D of I comma j. What do you understand this thing? D of 2 comma 1, D of 3 comma 1, or D of 3 comma 2, and so on. What is dissimilarity matrix? Dissimilarity matrix is also called object by object structure. Object by object structure. This one, data matrix, is called object by variable structure, and dissimilarity matrix is called object by object structure. দুটোই objected concept. So dissimilarity matrix is generally a collection of proximities that are available for all pairs of n objects, and this dissimilarity matrix is generally represented by n cross n table, n by n or n cross n table, and this dij. Ij means here in this case I is 2, j is 1. In this case I is 3, j is 1, and so on. So d of I comma j is actually a measured difference or dissimilarity between objects I and j, which I already told you. So in general, this dij is a non-negative number, generally positive number, and that is close to zero when objects I and j are highly similar or each other, near to each other. So এই যে diagonal element গুলো zero কেন বলতে পারবে? Why these diagonal elements are zero in this discriminated matrix? Why I have written these diagonal elements as zero? What do you think? These
Sir,
are not zero.
as they are close to zero, that's why.
No. Why they are close to zero? They are close. Definitely they are close to zero. Their distance between the two objects are zero. But why the distance between two objects are zero? সেটা জিজ্ঞাসা করছি। তোমরা তো কাজ করেছো অগমেন্টেড ম্যাট্রিক্স নিয়ে, তোমরা আগে কাজ করেছো। You have already done a work on with the help of augmented matrix. You have already done a work on incidence matrix. তো বলো এটা জিরো কেন? You should know it. Anyone? Why it is zero? These are not zeros. These have some values, which is a non-negative number or positive number. But why these diagonal elements are zero? Very simple. This one is what? If this is first row or first object, and this is also a first object, because this is 1, 2, 3, 4, 5, and this is 1, 2, 3, 4, 5, and so on. So this distance function is what? D of 1, 1. So distance between the similar objects is always zero. নিজের থেকে নিজের distance কি হয়? Zero হয় তো? Understood? Distance between
Yes, sir.
the similar objects is always zero. So that's why all the diagonals are zero. Because this is D11, that's why it's zero. This is D22, that's why it's zero. This is D33, that's why it's zero. And this is DNN, that's why it's zero. And rest of the values are not zero. Rest of the values has some sort of positive number or non-negative numbers. Okay, and this overall concept is called a dissimilarity matrix. Okay, or also called two-mode matrix. Now, there are various kind of data. These are the types of data in which the clustering analysis can be applied. Interval scaled variables are there. It is sometimes called numerical data. Okay, যেটা সবথেকে বেশি apply করা হয় clustering analysis এ। Binary variables are there which are represented in the form of 0 and 1. Nominal, ordinal and ratio variables are there. আমি already discuss করেছি ordinal variable. কেউ বলতে পারবে? মনে আছে কারো? What is ordinal variable? I already discussed. What is ordinal variable? Nominal means categorical. Nominal means categorical. What is ordinal? Categorical আশা করি সবার মনে আছে, male female. Okay, what is ordinal variable? What is ordinal variable? এটাও বলেছিলাম আমি, if you remember. Ordinal variable is such kind of variable which represents some kind of orders. কিছু order represent করে। ধরো ধরো আমাদের কলেজে ধরো প্রফেসররা একটা র্যাঙ্কিং এ থাকে। So the highest persons are professors, then associate professors, then assistant professors. Okay, then lab assistant. So these are the various ranks or orders on which the data object has been organized. In the same way, the military in case of military job, you have found several designations: general, then your lieutenant, several designation you will found there. So these are actually called orders. Okay, in which way the data are actually organized in the form of orders in meaningful sequence. Orders in non unmeaningful sequence. It should be a meaningful sequence order. And ordinal variables are very useful for registering subjective assessment of qualities that cannot be measured objectively. And like professional ranks, which I already told, like full professor, associate professor, assistant professor. Okay, so these are the various kind of ordering variables in terms of ordinal one. Okay. Now, how to make standardization of the variable? These things I already discussed during the. I think you have remembered it during the data mining initial chapters. I already discussed how to make a standardization. Okay, that means if you have a data set with a unnatural kind of data spread, unnatural kind মানে হচ্ছে ধরো you have a two attributes in your data set. One is age and another one is income. তোমার হয়তো মনে আছে, one is age and another one is income. So age are generally represents within the range of 0 to 100. Okay, generally within the range of 0 to 100. But income has been represented within a range of 50,000, 1 lakh, 2 lakh, 3 lakh. So there is a huge data disparity between these two attributes. And you have to apply a standardization process to reduce the data disparity and makes them or map them into a similar standard scale. একটা স্কেলিং এর মধ্যে ম্যাপ, 0 to 1 স্কেলের মধ্যে তুমি এজটাকেও ম্যাপ করে দিচ্ছ, as well as you will map the salary or income of that person. So it will be easier for classification as well as clustering. For both algorithm, it will be easier to handle such kind of standardized data sets. Okay, non-standard data sets বা unstandard data sets কে কিন্তু clustering বা classification এ apply করলে it will give you the bad results. Okay, and these are the process আমি বলেছিলাম, standardization with the help of mean, standardization with the help of z score standardization, এগুলো আমি বলেছিলাম, যদি মনে করে থাকো maximum minus minimum divided by maximum plus minimum, যদি মনে করে থাকো, I have already discussed about the normalization and standardization of data sets. Okay, so before applying the clustering algorithm, you can apply this standard, and this standardization and normalization is a process called pre-processing of data. So I have already given a few lectures about pre-processing of data. I have already discussed about in detail what is data pre-processing, how we can perform, and this standardization is a part of data pre-processing. Okay, now distances are normally used to measure. Now here look how many types of distances are there, how many kinds of distances are there. Look, these are the distance functions that we are going to use in our clustering technique. Okay, or in future, whatever clustering technique you will learn, you will have to use any one of these kind of distance functions. So distances are normally used to measure the similarity and dissimilarity between the two data objects. I already discussed about it. By the help of distance d of I comma j, we are able to measure the similarity or dissimilarity between two objects I and j, right? So how we can measure it? This is the property. If d of I comma j is greater than equal to 0, that means if a positive value. Okay, if it is greater than 0, that means it has some distance with the help of represented with the help of positive value. This is d of I comma I already discussed about in case of that dissimilarity matrix. That means the distance between the two similar objects is always 0. That's why the diagonal of that dissimilarity matrix are always 0. D of I comma j is equal to d of j comma I. That means the distance from I comma j, distance are always symmetric in nature. Okay, so distance from I comma j and j comma I are always symmetric. Okay, and d of I comma j is less than d of I comma k plus d of k comma j. এই জিনিসটা কেউ বলতে পারবে? What is the significance of this statement? D of I comma j less than equal to d of I comma k plus d of k comma j. দেখি তোমাদের mathematical sense কতটা. Can you say what is the significance of this statement? Rest of the three I have discussed. What is the significance of this last statement, last equation? What do you understand by it? Tell me, what do you understand by it? Anyone?
না স্যার বুঝলাম না।
I comma j তে পৌঁছাতে গেলে it has not any direct path. You have to go through another object. আরেকটা অবজেক্টের মধ্যে দিয়ে আমাকে যেতে হবে. That is called k object. It's the intermediate object. Understood? এবার বুঝতে পারলে? So you have to first reach from I to k. That's why the distance of I to k has to be measured. Then you have to reach from k to j. That's why the total distance will be added d of I comma k plus d of k comma j. Is it clear? বুঝতে পারলে? Clear?
না স্যার আরেকবার বলুন স্যার।
If you are going to calculate the distance between I comma j, there is no direct distance available or distance path available between I and j. You have to go through with an intermediate object, that is k. That means you have to first move from I to k, which is an intermediate object, and then you have to calculate distance from k to j. And then you are going to total or make a sum up of those two distances to make the total distance, or to calculate the total distance between I and j. So k is working like an intermediate object through which you can move or you can calculate distance from I and j. Without k, it is not possible because it is not directly connected, or there is no direct path available between I and j. Clear? বুঝতে পারলে?
Yes, sir.
Now, these are the various kinds of similarity measure metrics. Look, these functions are very, very important. Okay, in case of cluster analysis, it's very, very important. The parent function, or you can say the grandfather of all the functions is called Minkowski distance matrix. Minkowski distance matrix or Minkowski function. এখান থেকে বাকি ফাংশনগুলোকে derive করা হয়েছে. All the rest of the functions that we are going to use in our clustering techniques has to be derived from this Minkowski distance. And this is the father of all functions. And it will look like this. D of I comma j is equal to x1i minus xj1 mod to the power q plus xi2 minus xj2 mod to the power q plus dot 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 xip minus xjp mod to the power q.